University of Bridgeport. But except that there is no rule, no organization. That is unnormalized. That causes this kind of problem. So we need to make something organized one. The goal is remove redundant information. Solve the problem of the redundant information. How can we solve? We need to segment, decompose. That is the only solution, right? For example, because in this room, we have the faculty, student, and everyone. So why don't we cut by whether student or not? Then student will be here, and the other will be the next room. That is decomposition. So we will learn formal way. Using the mathematical term, we will learn this normalization form. I think that you heard about third 3NF. Third normalization form. Or for example, this database follow the 3NF, third normalization form, which means this database is organized. That's satisfied with the something condition of 3NF. So, how can we do that? We will use I hope this time one time. So far, I have mentioned about I used only redundant to explain about the problem, right? Redundant information. So we will we get rid of such a redundant information. Then how can we represent such a redundant or the problem of the bad example? How can we describe such a redundant information using mathematical terms? Math is nothing but the language to describe such a problem. So to do that, we will use functional dependency. Functional dependency means, for example, why don't you recall the employee. Employee table has social security number and so on as the primary key, and address, first name, last name, and so on. Functional dependency means, anyway, what is a function? Function. I think you learned the definition of function in your third grade or first grade. I checked all the country, including United States. You learned in your the elementary school. What is a function? Data structure. No, that is not computer science. I'm sorry. This is the function of math. Yes. Method to fix the problem. Mapping.
From one domain to another.
Equation. Yes. Equation is another representation of the function. Function is, for example, when I learned the function first time, my math teacher at the time shows that this one. So this is the input, this is the output. So when I put the number 1, output is 2. When I put the 2, it's a 4. 3 and 6. What is the output of 4? 8. So it's a times 2 function. So we can say f is a function. Function of x is 2x. Or we can use y equal to x. It's an equation. It's a function. I'm not very good at Chinese. I think something similar, right?
Yeah.
To write the function.
Yeah.
I cannot remember exactly. So I learned the Chinese character how to write, but it's too many to learn. So I forgot most of them. I can write my name. Actually, this is my name.
Yeah.
Not bad. Anyway, so this is a function. So functional dependency means we are going to use the function to describe, to explain about the problem, but it's the functionally dependent. Dependent means, for example, a set of attributes determine another set of attributes. For example, social security number, using the social security number, you can identify all attribute, right? For example, address. What about social security number? Determine first name, last name. However, using address, you cannot find social security number. That doesn't make sense. So, in case a group of attributes, it doesn't have to be one attribute, it can be two or more. One or more attribute. Determine one or more attributes. Sometimes address plus last name you can find. This is called functionally dependent. Address is functionally dependent of SSN. Okay, this is called functional dependency. Then you can find as many functional dependency as possible. For example, column A is a primary key. B. How many functional dependency can you find?
One.
Only one?
Like
Yeah, that is A determine B.
B.
Right? What about
A determine A, B.
A determine A? Yes, it's true.
Yes, yes.
Yeah.
What about A determine A and B? Is that all?
No.
What else?
A, B determine A.
A, B determine A. A, B determine B. A, B determine
A, B.
AB.
A, B. It's not infinite, and however, you can find as many functional dependency as possible. However, we don't need all functional dependency, but what we need is minimal functional dependency. That's, in other words, is a core functional dependency of this table. That is, A determine A and B. Okay? It's a minimum. Actually, this one is the minimum because it's obvious. So A determine B. It's a minimal functional dependency. Okay? So, if we have such a minimal functional dependency, okay, that describes actually, where is that? One meaning. So I explain about the first informal way of goodness of the database design. One meaning for one table. One meaning, when I say meaning, is it the computer science terminology? No, it's not computer science. It's just a dictionary. The normal definition of the meaning. Okay? Nobody answer what is the meaning of meaning. Nobody ask, actually. Because that is an informal way. But in formal way, using mathematics, using the function, we can describe such a meaning as the minimal functional dependency. In other words, how many minimal functional dependency for each table? One. That's the best one. In other words, if you can find multiple functional dependency in one table, there's something wrong. It may have two meaning or three meaning. In other words, it may have redundant information. So, first job is you need to find such a minimal functional dependency from the table, then we will use such a minimal functional dependency to normalize. Can you get the idea how to decompose? Our goal is one meaning for each table. In other words, one minimal functional dependency for each table. In case you find the two minimal functional dependency, that means we need to segment. Okay, we will see such a thing. Within 5 minutes, I will finish chapter 15. Very long introduction. Actually, I explained most of them already. The reason is that I didn't charge my laptop. No, just kidding. So, our goal is, so we will do the first you should be able to make the first normalization form or second or third BCNF. The good news is, even though you do not learn this one, if you follow, even though you do not have the experience on the database design, but how many of you use the relational database like the SQL Server in your the programming course before you take this one? Some of you already take. Is there any problem to design? So you are using just the create table and just create without considering anyone, just the student table. This is a customer table. Do you have any problem of the redundancy? No. The reason is that if you are normal person, normal means just normal, not normal in the computer science. If you are normal person, you can design automatically up to third normalization form. Okay? The problem, the good news is you can do it up to the third normal form without understanding any complicated stuff that I explained today. The bad news is the problem usually caused by after this. So 95% I guess can be covered by third normalization form. So there is no problem in your programming course even though you use the relational database model or relational DBMS because it requires only the third normalization form. That's 95%. But most of the problem caused by after this. So we will discuss about the BC up to the BCNF. So the informal way of such a goodness of the database is the first guideline and second guideline, third and fourth guideline. I will show you the example of the, I think that you understand first, second and third guideline easily, but the join problem is the Freer's tuple is, for example, we write, this is the example of the bad example of the design. First one is employee underbar location, and second is employee underbar project. So it doesn't follow the even first, second, and third guideline. But when we join such a bad example of the database design, it will cause some unexpected data when you join, when you combine two tables, because it's bad. For example, so you join these two tables using project location. Okay? Project location is the same command, so I try to join P location is equal to P location. But it calls one to, for example, the first one is okay. So it's a social security number 1 through 9 and project number 1, 32.5 hours and so on. It's not a problem. But second thing is project name, project location value is the same. But 1, 2, 3, 4, 5, 6, 7, 8, 9 is actually not English. Okay, that is the reason when you join project at the department, your midterm exam, many of you actually do not use department. Instead, you join the number in project. equal to the number in employee, right? That may cause such unexpected data if your design is not good. However, in our case, the company database is perfect. So it doesn't cause the problem, but so to guarantee the correct output, you should join with the department. Anyway, in this case, the second law is not a expected data, it's unexpected spurious data because it's a bad design, like this one. Okay, that is the. Then I will show you more example of the normalization. Okay, in the next class. And I'm going to change a little bit about the schedule, our schedule, because of the little bit delay of the schedule. I actually expected the last week some advanced topic or the current topic on the database research. I will take out that part instead. I will finish our lecture up to the transaction control. Okay? And also, if possible, I'd like to have the exercise lab for query optimization as well as query processing. Any question? If you have a problem or question regarding to the makeup exam, you can come by my office right after this.